Hello everyone. In today's lecture, we are going to discuss about the signal description of 8086. Signal description is nothing but the pin diagram of 8086. So 8086 is a 40 pin IC. Okay. So here with pin number 1, the ground pin starts, and then here 40th pin will be the VCC pin. So leftmost is ground and rightmost is VCC, which is a basic connection which has to be given whenever we use this IC. Along with this 8086, if you see, we have data bits, address bits. So these are the ground pins 1 and 40, and then we have pin number 20 also as ground pin. Here the power supply, 5-volt power supply is required for an 8086 to operate. Then pin number 19 is known as the clock pin to give the clock signals. And pin 21 is the reset pin. Then we have address bus. We have 16-bit address bus. So if you see from A0 to A9, A14 and then A15. Altogether 16-bit address bus is available. And then we have the address latch enable pin also. When the address latch enable pin is high, multiplexed address or data bus contains address instruction, right? So this pin, that is the 25th pin, it is used as ALE, address latch enable. Whenever we are using this, ALE will go hand in hand in order to enable the address bus. Then we have two interrupt pins. One is INTR, that is pin number 18, and then another one is NMI, that is pin number 17. This 17 and 18 are interrupt pins. So one is NMI is non-maskable interrupt, and 18 is interrupt request pin. See, interrupts can be of two types, that is maskable interrupts and non-maskable interrupts. Whenever a system generates interrupts or whenever a subroutine occurs as an interrupt, certain interrupts can be masked. Certain interrupts can be put in wait mode and can be executed after execution of particular instructions. But there are certain interrupts which could not be masked and which should not be masked. That is, if a battery is low, then the battery low indication should never be masked. Immediately it has to, the display has to pop up, and then it has to be intimated to us, or else the system will be shut down, right? So this is a kind of non-maskable interrupt. At any cost, whatever the kind of programming you are doing with, whatever the program is being done, is being executed, it doesn't bother about anything. If the battery is low, less than 5, immediately it will give a prompt that the battery is low, right? That is an interrupt which cannot be masked and which should not be masked. Those kind of interrupts are known as non-maskable interrupt. There are other interrupts which are maskable interrupts too. So whenever an interrupt occur, then interrupt acknowledgement pin also should be enabled. Interrupt acknowledgement, once if it is ready to service the interrupt, once if it receives the interrupt acknowledgement, then only the interrupt will take place. Other than this, we have hold and hold acknowledgement. See, if you see here, this 8086 will operate in two modes. One is minimum mode and another one is maximum mode. See, this is differentiated by the pins 24 to 31, whether it is minimum mode or maximum mode. It is differentiated by pin number 24 to 31. If it is in minimum mode, then all these functions, ALE or interrupt acknowledgement or hold acknowledgement, all these will be executed. If it is in maximum mode, then these pins will be executed. So how it is decided, whether it is operating in minimum mode or maximum modes, it is decided by the pin number 33. If pin number 33 is 0, then the 86 processor will work in maximum mode. If the pin number 33 is 1, then the 86 processor will operate in minimum mode. So minimum mode is the commonly used mode. Then we have the address bits and status bits. These bits, here you see here the address pins 16, that is AD0 to AD14. They act as address and data buses. That is why it was mentioned as AD, right? Address and data buses. And if you see here, these buses acts as address bus or status buses, right? Right here we have the status buses, so it acts as status buses. So here we have mentioned what is the meaning of S3 and S4. If S3 and S4 are 00, what is the function? That is, extra segment is in operation. Similarly, 01 stack segment, 10 code, here one, the first one is S4 and this is S3. 10 code segment is working, 11 data segment is working. That is also mentioned here, which segment is being in operation, right? So this is used to indicate the segment, right? And if you see, the other S6 will be in logic 0 and S5 indicates the condition of interrupt flag bits. Then another pin 34 is bus high enabled, enables the most significant data bits during read or write operation. So when you see here A0, what is the function here? And as already discussed, we have minimum mode and maximum mode pins. Minimum mode or maximum mode is denoted by pin number 33. Either it will be set to 0 or 1. Then other than this, we have in maximum mode, we have the read signal, we have the write signal, we have the memory signal, we have data transmit and receive signal, we have the data bus enable signal, and all these signals are also available. These takes place whenever a read write operation is taking place. Then we have the status signal. We have three more bits. Here we have only four, that is S3 to S6. We have S0 to S2, right? Status signals are there. Here this status signal shows this when S0, S1, S2 is 000, it acts as an interrupt acknowledgement. That is what we have denoted in this pin. Here we have denoted the same. So it acts as a status acknowledgement. Here it acts as a read IO port. Here when S0, S1, S2 is 010, it reads as it acts as a write in IO port. Then if it is 110, it acts as a halt. From S0 I am mentioning. From 101 it is read memory. From 011 it is write memory, and 111 it is non-passive. Then we have two more signals, that is lock output, and then we have DMA request and DMA grant pins. Pin or also the DMA is direct memory access. Memory can be accessed directly. That is a separate concept, and if it works, then these pins has to be enabled. Therefore, a DMA request has to be made if you want to access DMA. If you want to access the memory directly. And once if we receive the grant, that is acknowledgement signal from the direct memory, then only the data can be transferred to the memory directly. Then we have Q. Q status is also mentioned here. Q is idle. What is the position of Q? Is it idle, or is it using bits, or is it empty? All these statuses are also mentioned here by bit number 24 and 20, bit number 25 and 24. So all these are for your reference, and you can go through these pin details quite patiently, as the working of 8086 should be mapped with the pin details. The programming model should be, or the instruction sets should be mapped with the pin details or signal descriptions. Whenever a signal is being read, what is the basic operation, how the buses are accessed, all these is attached with the signal description. And so thank you. Here you have an assessment question, and thank you.